If there are more terms, does it just start in the upper right corner and move diagonally across? Or diagonally down? If you have more alpha terms, like
Yes.
more than 2p loadings.
Yeah, so usually it's alpha 2, 2,
Remember those
alpha
zeros?
n, and then alpha 1, 2, alpha 1, 3, alpha 1, n. So this is symmetric. Good. So that's your questions. Good. So that should be that in that way. So this is, we consider a beam, and we have the loading P1. The loading are the same. We have two loads, magnitude, and then this is L over 4. L over 4, and this is L over 2. So for this case, the loading applies symmetrically, but doesn't have to be. Okay, so for these illustrations, we have the beams, we have Young's modulus, and we have moment of inertia. And so for this case, we want to calculate is the total strain energy. So the same thing, I think the easiest way is we draw the plot, we draw the diagram, and then we simply look at the drawing to formulate the information we need. So let me call this is point D, and this is point E. So for the drawing, follow up that's concept here. So this is displacement. This is for the loading at D. So this is the loading at E. Okay. So for loading at D, we're going to increase, for example, gradually increase the loading to P, and then we stop there. And in the meantime, the second loading at E, we have no applications. So basically, this stage is denoted as our stage 1. Okay, so for this stage, we what information we need? I think what we need is the displacement at point D and due to loading at D. Okay? So at least we need to know what is this amount. You can use whatever the symbols you like, but here I would like to keep with the symbols we use in our textbook. And again, the first one indicates locations, and the second one is due to the contributions from which labels of the loadings. And from here, what is XDD? XDD is in this case, on the separate kind of scratch papers, you can write up like this. So this is the loading P, and then this is the diffractions. So here is XDD. That is our notation for the symbols. And what is XDD?
The first
My
one.
goodness, during my lectures, you watch your smartphone and then reading some social media. I'm going to tell your parents. I'm going to tell your parents. Recording, right? So I'm going to extract this one and send over to your mom.
It's all right, they're in China right now.
Yes. Okay. So what is XDD? So looking at the appendix, and from the appendix, I think we can go for which case? 1, 2, 3, 4, 5. Case 5. Appendix D and case 5. From case 5, we should be able to calculate So for this case, this is the L over 4. This is 3L over 4. Okay, so x equal to L over 4. So in this way, we do the calculations. And for the case 5, the diffraction is the P times B. If you have the handouts with you, probably I won't go over it. So B for this is PB. Let me write it out the equation first. So here the B equal to 3L over 4. Okay? So we're going to calculate x, the value at x equal to L over 4. So that we simply plug in everything here. And so for the first time, I will try to implement everything in details, but later on I will directly copy my answers. Okay. So for this case, that is L over 4 cubed minus L squared minus B squared and L over 4. And this number will give us is minus 768 and PLQ EI. And here we completed it with a minus, but here we only focus on the magnitude. So for whatever the information we only take up is the magnitude. So in the later calculations, I would say the XDD would be equal to 7, this one. Let me write up here. So XDD will be equal to 768 EI PLQ. Okay? We only take up the magnitude. We don't care about the sign. And this minus, if you look at the appendix, that indicating the diffraction is downward. That's it. It means nothing. Just means it's downward. Okay? And so this is stage 1, and then in stage 2, we apply the loading P. So in the stage 2, the loading at point E will gradually increase to the magnitude, and that's called the P. So in stage 2, we mark the end of the stage 2. So that for this case, the loading applications, and again, look at this one, that will give us the loading, let me call it XQQ or XE. Okay, this XE corresponding is this case, this one. For this case, can you see this exactly is the same, will be the same calculation we did here? Yes? No, sorry.
Yeah, because that's greater than the
No.
Your notation on your original diagram is fine. Because L for the loading of E, wouldn't L be 3L over 2 or 3L over 4?
Yes. So let me double check with this one. Oh my goodness. If you have the handout with you, I made a mistake here. So let me modify this one. So that is 256 into 3. Okay, so that is the first one. And now we focus on this one. So for this one, everything, we can change this one quickly here. So that will be when XE, we do the calculation at 3L over 4, right? Okay, so that is for this case.
So B would not be 3 over 4.
So B will be, yes. So B will be L over 4. This is 3L over 4. Okay, so we plug in everything. And then the result will be the one, I copied the wrong numbers, sorry.
So you flip them?
Mm-hmm. Yes. Not flipping. This one is the same. Are we okay?
Well, on our sheet it says for x less than a, use that equation, so why are we using that both times?
The x less than a is for only the maximum deflection,
Mm.
right?
That's not for the maximum deflection.
Oh, yeah.
That's for the equation.
For that, for the sheet, it's saying that for x more than a, and we use this equation y equal to certain something, and x cubed minus something, x squared something. This one indicating is this. So right now for this case, this is the a. This equation is the y of the x, that describing the diffraction, which means describing this portion. Okay, so this equation is for describing the diffractions in this range, including this point, including this amount here. That's the meaning of this one.
But if we don't know the deflection right away, how do we know that x is?
We don't know the diffraction.
So you're just guessing that x is less than a?
Yeah, so here we have the equation, right? So for example, for this case, we want to know what is the diffraction at x equal to a, and a for this case is 3L over 4. And then that is what we calculated here, right? And then B is about the geometry. So B is the location here. So this is the B, and for this case is L over 4. Okay. And now for this case, due to the application of the P, we have the loading at D due to E. So that means this number actually is this number here. Can you see it? That number is this one, is called the XED. And again, what is this one?
E.
That amount is equal to this one. What means this one? This is the diffractions. This meaning the diffraction contributed by application of P2. So that is actually described in this scenario. So that means XED, let me copy this equation. XED equal to diffraction of Y at list locations, L over 4, at X equal to L over 4. And then let me copy that equation here. And that in that equation appendix we have is PB 6EI L x cubed minus x squared minus b squared and x. And for this case, we calculate at this number. And for B, for this case, is that dimension here. Okay, clear? Okay, so that one, do this one completely, this number will be minus. Okay, that one up here. 768 EI PL3. So here again, we don't care. We don't care about the minus. So basically, let me get a minus here, artificially. So here is the XED. So we have XED, and this is the stage. So the total strain energy is the area 1 plus area 2 plus this square, the rectangle 3.
So is it ED or DE?
Either way, that one here we applied for the Maxwell, alpha 1, 1, alpha 1, 2 equal to alpha 2, 1. So that means the corresponding for this case. Maybe you can calculate, okay, either way. So let me finish this one quickly. So U1 will be equal to 1 P times XDD, and X2 in this one, that is 1/2 P times XE. And for the third one, that simply is magnitude multiplied with XDE. Okay, so this result, that one will be equal to 48 EI P square L3. That's it. And my experience, most of the time, for the first exercise, for the first time exercise, most of the time, the most kind of the mistake prone steps will be here. Okay, but that one is simply the application of this case. And for your review, the two either scenario will be the key for you to understand and exercise which exactly what amount you calculating. Okay, so that is the key for this one, for this portion here. Okay.